Hello students, I'm coming today to talk about statistics for AP Psychology. This is just an overview of some of the main things that you need to know for this class. It is certainly not a comprehensive review of statistics, and you don't need a comprehensive knowledge of statistics for this class. You just need to be able to understand the data that you're reading. These are the terms or concepts that you might run across in an AP exam. Either for the national exam or for one in our class. And so I'll be talking about descriptive statistics, correlation, and inferential statistics, especially significance and p-value. So let's start with descriptive statistics. These are used anytime we're merely trying to describe a data set. So I have two data sets here as an example. They're fictional, but let's say that I have done a survey and I am wanting to describe the number of hours that students at Edina and students at Lincoln do homework each week. And I make a histogram, which looks like this, and these are my data set points, number of hours per week. So we see that Edina, we have 1 6, 2 8s, 3 10s, 2 12s, and 1 14. Lincoln's data is a little bit more compact. We have 1 8, 2 9s, 3 10s, 2 11s, and 1 12. So the first measure of central tendency, probably the one that is really important to know, is the mean. The mean is merely the statistical average of your data set. So if you take the sum of x, so the sum of the number of hours of your data set, and you divide it by n, the number of items in your data set, then you get the statistical average, or the mean. So if we look at both EHS and LHS, even though their data sets are slightly different, they both have end up being 90 divided by 9, or an average of 10 hours of homework per week. The median is going to be the central value. So basically what you do to find the median is you count inward from the two outside points. So we have 6 and 14, then we have 8 and 12. We've got two data sets there, and our median is 10. Turns out our median is 10 for Lincoln as well as the mode, and the mode is the most frequent value. So there are some practice questions that you can look at in your Unit 1 folder, but how do the three measures of central tendency compare for EHS and LHS? Well, they're all equal to 10. So the average, whether it's measured as mean, median, or mode, is going to be 10 for both data sets. What will vary, however, are the measures of variability. This tells us about the spread of the data. And basically, the way that you find this is you just subtract the highest value, or the lowest value, from the highest value, and that will equal your range. So the range for EHS is 14 minus 6, which is 8, and the range for LHS is 12 minus 8, which equals 4 hours. So we can see that the range for LHS is just half of what it is for EHS in this example. Now, something that's helpful for us in understanding variability is the standard deviation. The standard deviation basically just means what is the average distance from the mean. So if we look at Edina versus Lincoln, which one is going to have the largest average distance from the mean? It also tells us about the spread of scores and the value of the mean in representing typical scores. So if you have a small standard deviation, that tells us that the mean is a good representation of the average performance for a group. In this case, we know that LHS has a range of 4 and EHS has a range of 8. We don't need to do the standard deviation calculation to know that the average distance from the mean is going to be smaller for Lincoln than it is for Edina. Therefore, the standard deviation being small for LHS is going to tell us that 10 hours per week is a good measure of how many hours per week Lincoln students study, which is 10. Okay, so again, check your textbook if that doesn't make sense to you, but the thing to remember, just to reinforce, A larger range is going to lead to a larger standard deviation. A smaller range is going to lead to a smaller standard deviation. And with a small standard deviation, that mean is going to be a good representation of a typical score or data point. Now we have the normal curve, and this is actually really important in psychology and in psychometrics. When the mean, the median, and the mode are all equal, then we have a normal curve. And the normal curve is sometimes called the bell curve. Now, it could be very steep or it could be very broad, but if this occurs, the mean and median and mode are all the same, you will see this general pattern. First of all, you will have standard deviations marked on the bell curve. So if we see any X with the line over it means mean. This is +1 standard deviation, +2 standard deviation, +3 standard deviation, and so on the negative side. In any normal curve, regardless of the data set, 68% of the population will score between plus and -1 standard deviations from the mean. 95% of people will score within 2 standard deviations of the mean, and 99.7% will score within 3 standard deviations from the mean. So let's say you have 200 people that take a test. Their test scores follow a normal curve. How many will score between plus and -1 standard deviation from the mean? Well, you take the 200 test takers times the 68%, or 68 with 100ths, and you get 136 people that will score between plus and -1 standard deviation from the mean. Now, the average IQ is a very important measure in psychometrics, and it's used in a lot of tests, like the Wechsler test and the Stanford-Binet intelligence test. The IQ test is normed so that the average IQ is 100. And IQ, or intelligence quotients, follow quite closely the normal curve. The curve is set such that the standard deviation is 15 points, and so 68% of the population falls between 85 and 115 on the normal curve for IQ. If someone scores 130, they have what's called the Z-score of +2. Z basically just refers to someone's score based on their standard deviation from the mean. So if you have a Z-score of +2, then you have an IQ of 130. Someone with a Z-score of -1 will have an IQ of 85. Now, 95% of the population will have an IQ score somewhere between 70 and 130 if we look at 2 standard deviations from the mean. This is pretty significant, actually, because 130 is considered gifted and 70 is considered cognitively disabled. And people who score below 70 on a standard IQ test will generally qualify for Social Security disability benefits. So this is a curve I would be familiar with and make sure that you understand. If you have any questions about this, please come to my office hours. Now let's look at skewed distributions. In some cases, the mode, median, and mean are not equal. And actually, it's a few extreme values that may skew the data in one way or another. So let's say that we have 6th graders taking a high school math test. Most students are going to score poorly because they haven't actually learned a lot of the concepts that high school math students have. However, there might be a few of those students, maybe some kids who are in an UMP or something like that, who kind of pull the tail of that curve to the right a little bit and extend it. This is going to lead to what we call a positive skew. You might call it something different in your statistics classes. In psychology, we call it a positive skew because it is pulled to the right a little bit. And so we have the mode here, the median, and the mean. As far as a negative skew goes, let's say high school students take a 6th grade math test. In this case, most of the students are going to do pretty well. So we're going to see our mode here quite high. However, there will be a few low-scoring students, and they're going to pull the curve a little this way and pull the median and mean a little bit that way, so that this will result in a negative skew. Like I said, you might call it something else in your statistics classes, but remember, for this class, this is a negative skew and this one is a positive skew. Now, the correlation coefficient I did talk about in another PowerPoint, so I'm not going to spend too much time on this, but I do want to emphasize two terms here: relationship and prediction. Correlation coefficients take a look at two behaviors or events or other characteristics that can change or vary in some way. Now, psychologists might use other methods of research, such as surveys, archival research, etc., to collect their data, and then they plot them on a scatter plot. The main thing to remember about the correlation coefficient, or correlations in general, is they are not causation. They do not equal causation. So the correlation coefficient is denoted by the letter R, meaning relationship, is equal to, and this is a number between +1 or -1. The closer the number is to +1 or -1, the stronger the relationship. So in other words, if I have a correlation coefficient R equals -0.95, that is going to be a very strong negative correlation. If I have positive 0.95, that's going to be a very strong positive correlation. So the difference between a positive correlation is that there's a direct relationship between the two variables. So if we take a look here at this one, hours of studying per week and grade point, we see a positive correlation. That is, as one variable goes higher, the other goes higher, and the direction of the scatter plot will be upwards and to the right. A negative correlation has an inverse relationship. In other words, as one goes higher, the other goes lower. So we can see here that as the number of hours of TV watched per week goes lower, the grade point average gets lower. So a zero correlation, basically the scatter plot looks something like this, and there's really no relationship. This, by the way, shows a stronger relationship than this one if we were to do the calculation, because you can see the scatter plot points are closer together. Remember, correlation is not equal to causation. And this is something that I feel like, we need to give politicians or something a lesson on this, because so often studies are pointed out about the correlation between X and Y, and, how this is a bad thing and we need to do something, but we can't determine causation from this. So does time on the internet cause depression? Maybe. Does depression cause someone to use the internet more? Maybe. We know they're correlated. Actually, research has been done and has identified a connection, a correlation between internet use and depression, a negative correlation. But is that really, does one cause the other? Or is there an unmeasured third factor, such as low self-esteem and isolation, that causes one to be both depressed and using the internet more? So that's why it's important to remember that correlation is not equal to causation, because there might be that unmeasured third factor. Now, the final thing that I want to talk about here is making inferences, especially using what we call p-values and statistical significance. So for this, we're going to be wanting to compare two data sets. So we have the data set from the control group and from the experimental group. So let's say that I have a computer-aided reading program for 5th grade students. I have a control group, and after the period of time that I've been using this program, this reading program, this is the data set for the control group. Now, the experimental group, their data looks like this. The data sets are far enough apart that without even doing the calculations, I could probably say with a fair amount of confidence that the computer-aided reading program appears to have had a significant impact on students' reading ability. So how do we describe this then? We're going to see it described in one of these three ways. And this is really all you need to know for this class when it comes to p-values. So if you see this, they all mean the same thing, by the way, then you would read that as the probability the results are due to chance is less than 5%. 5/100ths, as you know, is 5%. If you see this 0.05 level of significance, you would say the hypothesis was confirmed at the 0.05 level of significance. If you see 95% confidence, then it's all the same thing. We are 95% confident that the results are not due to chance. In other words, they're due to the action of the independent variable, which in this case is the reading program for fifth graders. Now, there are different levels of significance that might be described. They might even have a bar as high as 3/100ths or 3% level of significance. And that's something that in more advanced classes you would take into consideration. So thanks for listening. I hope this has been helpful to you. And if you're still a little confused, come to my office hours or take a look in the Unit 1 folder for further information. Thank you.